Okay guys, DNS exam 4, problem number 15. I saw this question posted yesterday. I swear to you guys, I did this, I worked it out, and then after I did it, I realized my microphone turned off and there was no sound. So we're going to try it again right here. I felt like they made this problem maybe a little bit more complicated than they needed to. It seemed like there was a way to ask what they were getting for, or getting at here, without maybe being as convoluted as they needed to. But we've got a table right here, 5 values of t and then corresponding values of f of t, and they're telling us here that the definition of g of x is a definite integral from 1 to x of f of t dt. And the question they were actually asking us here is, what is the value of g of 15 minus the value of g of 1? All right, so that's what we're looking for right over here before we get done with this whole mess. And it seemed to me that as soon as they gave you f being defined, or excuse me, g being defined as the integral of f, and that they were asking us for the difference right here between g of 15 and g of 1, this really seemed to me to be an FTC Part 1 question. But then as I was looking at it more, I thought, you know what, that might be making it more complicated than we need to. We actually have the information at our disposal right here to go ahead and find the value of g of 15 and also find the value of g of 1, and then simply subtract those two values from one another and answer the question straightforward. So I actually want to start talking about g of 1 right here, because if we go back to the definition of g of x right above, we can see here pretty quickly that g of 1 is just going to be the definite integral from 1 to 1 of blah, blah, blah. It doesn't really matter anymore, because now that we see we've got the same limits of integration on both the top and the bottom, we know that the value of g of 1 has to be 0. G of 15 is going to be a little bit more complicated than that, but we can still do it. G of 15 then, again, going back to the definition of g of x above, is the definite integral from 1 to 15 of the f of t function taken with respect to t. Now, we can't actually answer that question straightforward right now with 100% accuracy because we do not know the explicit definition of f of t, but the directions to this problem tell us to go ahead and use a left Riemann sum in order to approximate the value of that integral. So, to do a left Riemann sum, we're going to take a look at our first subinterval, which goes from a t-value of 1 to a t-value of 3. And because we're doing a left-hand approximation, it is the value of the function evaluated at its left endpoint that we're going to use to tell us the height of the rectangle. So, something you guys have seen me draw on occasion before would be a weird shape that looks maybe something like this. Our interval goes from 1 to 3 up there on top, so the width of our first rectangle is 2. Actually, I think we're going to do this in our heads, guys. The width of that first rectangle from 1 to 3 is 2, and the height of that rectangle, which got evaluated at its left endpoint, is also 2. So 2 times 2 tells us the area of that first rectangle is 4. And now what we're going to do is go ahead and slide this goofy shape over here just a little bit to the right. The second rectangle goes from 3 to 6, so it now has a width of 3, and its height at its left endpoint now is this 3 right here. So 3 for the width times 3 for the height, and we get 9 for the area of the second rectangle. Let's keep moving on over to the side here, guys. All right, third rectangle goes from 6 to 10. It's got a base or a width of 4, and the height here from the left endpoint is 4 as well. Boy, they're stuck on perfect squares right here. So 4 times 4 is going to get us 16 now for the area of the third rectangle. And the final rectangle right there, guys, sorry, goes from 10 to 15, so it's got a width of 5 and a height of 2. So we're going to add a 10 to that, and we're going to put all that together, and let's see, 4 plus 9 is 13, plus 16 is 29, plus 10 is 39, for our estimate right there for g of 15. So again, right back here, guys, to the problem itself, they wanted us to come up with the value of g of 15 minus g of 1. Well, g of 15 we approximated to be 39. G of 1 we knew for a fact was 0, and our answer right there is 39. And I did not bring my book down here with me here, guys, but I'm pretty sure that answer is D. Regardless, the 39 is correct, so go with that.